So it looks like today will be the last class, and the final will be on 2 weeks from now, December 18. December 18. It's going to be 3 hours. So you can prepare 3 pages of cheating sheet. So that means you don't have to memorize all the formulas. I mean, you can just write down. And probably the time that you are preparing for your cheating sheet is most likely the only time you study, in my experience. About 80% of the students just spend maybe 2-3 hours for preparing for the cheating sheet, of course. And if you have any questions or something, you can ask me by asking this email. For the inquiry. So before I proceed, any questions about the finals? No? So I guess 2 weeks will be enough for you to prepare for the final, right? You need to have some time to study. 옛날 퀴즈도 올려놨나? So we have been studying that the Fourier transform is given by this. And ft is 1/2 pi d omega. Yes, so it's called the Fourier transformation. Am I loud enough? So Fourier transformation is in a way the generalization of a Fourier series to the arbitrary functions. The Fourier series is for the function with some particular period big T, and the Fourier transform is the case when that period becomes infinite. So before I proceed, there is one particular integration you need to know. It's called Gaussian integration. And this is actually given by pi over a. So anyone who has been learned about this Gaussian integration, raise your hand. Is it your first time to encounter? Actually, we did in the spring semester when we were learning about the Laplace transformation. That I think I did cover that Gaussian integral, but I guess our memory span is quite short, right? So 6 months is quite a long time to retain the memory. So let me just derive it. It's very easy. I think even some high school reference book contains this integration. 수학의 정석. I think they have that this Gaussian integral as one of the example problem called 필수 예제, right? So let's just do square by square is I times I, right? So we can say ax squared dx times y squared dy. We can use the integration variable is just dummy, so you can either use t, x, y. It doesn't really matter, right? So you can put this as a x squared plus y squared dx dy. Then you can use polar coordinate. Use polar coordinate. That is x squared plus y squared is rho squared. Dx dy is rho d rho d phi. Using this polar coordinate, then I square becomes dx dy exponential minus a x square y square. You can transform this as a polar coordinate 0 to 2 pi, 0 to infinite, rho d rho d phi exponential minus a rho square. Rho square is x squared plus y squared. This is your polar coordinate. And there is no dependence of phi and the integral, right? There is no phi here, so this is just 2 pi. Two pi times 0 to infinite exponential minus a rho square rho d rho. And if we set u as a rho square, tu is 2 d rho, right? So it becomes 2 pi over exponential 0 to infinite minus a u du over 2. So it becomes pi times exponential minus au du. So that becomes pi over a 1 minus exponential a infinite. It becomes 0. That is pi over a, right? So therefore, I is square root of pi over a. So let's try to find the Fourier transformation of when ft is exponential minus at squared. Then the Fourier transform becomes infinite, minus infinite to infinite, exponential minus at squared, exponential minus I omega t dt, right? So you can just put it together as exponential minus a t squared plus a of I omega t. You can add such as 4a omega square plus 4a omega square dt, right? So this is basically 0. You add something and subtract the same thing. But it turns out that, this becomes what? this becomes t plus 2a over I omega square, right? So it becomes exponential minus 4a omega square exponential minus a t plus 2a I omega square dt. So we can change the variable again. T plus 2a over I omega as u, dt is same as du. Then it becomes minus, sorry, I just put it down. Omega square over 4a minus infinite plus I omega over 2a infinite plus 2a over I omega exponential minus a u du. But actually, what happens if you add something to the infinite? Some finite number to the infinite. Still infinite, right? So this becomes basically infinite, and this becomes minus infinite. So the integration becomes pi over a exponential minus 4a over omega square. Okay? So I just let you copy. So that means Gaussian, if we have a Gaussian integral, the Fourier transform of Gaussian is again Gaussian, right? But just different domain. From Gaussian in T becomes Gaussian in omega. Okay. What happens if you have a complex conjugate? Right? So here, T and T prime is a domain, so you can use either variables when you do the integration. So the absolute value of this omega square is f omega times f star omega plus conjugate. Prime ft prime complex conjugate exponential I omega t minus t So f omega square is dt prime ft f star t prime exponential r omega t minus t. So when you integrate over the d omega, dt, it becomes dt prime d omega. We have done this before, right? Previously. What is this? It's called delta function. So it becomes 2 pi delta t minus t. So it becomes 2 pi dt prime ft f star t prime delta t minus t. So it becomes just 2 pi times minus infinity to infinity dt ft square. Amazing, right? So in summary, this is very important property. It does have a name for the possible theorem. It does have a name. So, summary. It's called Parseval's So if I talk to somebody, to my phone, the information in my voice is a function of time, right? So when I talk to somebody, oh, sorry, I almost called someone. So if I call someone, but when I talk to somebody, my voice information is in function of time, right? So this is ft. What your iPhone does is transform this function into the function of frequency omega. So what is actually transfer is in terms of this. And somebody is receiving your phone. Then you're listening something that is function of t again, right? So this becomes the blah, 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 f prime t. The possible theorem says the information contained in your original voice and transformed into the radio wave is, say, conserved. So the information contained in function of time is contained in the function of omega and transformed into the next your friend's handphone over the wave. So in the process, that information here is ft squared in the voice information transferred through wave, electromagnetic wave in omega square is conserved. That's the reason why we can communicate over the distance with someone using your iPhone or maybe Galaxy, whatever. I just saw the YouTube announcement that Tesla is going to announce their own their mobile phone, right? So whatever the mobile phone is, when I talk something, then it's a function of t. But when transformed over the wave, it's function of omega. And this possible theorem can be used to calculate very interesting integrals. That's one of the applications. The possible theorem can be used to do some integration. For example, I the complex variable is another one of the high-performance computing machine about 200 years ago. I told you about that. But the Fourier transform can be also used to do some integration using possible theorem. So assuming that I ask you to do this integral, sine square x over x squared dx from 0 to infinity. Give a hint. If ft is given by the following function, 1, 0, what is the Fourier transform of this function? F omega becomes minus 1 to 1, right? Minus I omega exponential minus I omega minus I omega. That is twice of omega sine omega, right? So actually we know that possible theorem copy. So this is the case that we know the answer. I'll just let you. So when f omega is twice of omega square sine omega, f omega square is 4 times omega sine square omega, right? So from Parseval's theorem, minus infinity to infinity, f omega square d omega is 4 times omega square sine square omega, right? That's actually 8 times 0 to infinity. D omega, right? That is 2 pi times minus infinity to infinity ft square dt. But ft is only has value only between t equal to minus 1 to 1, right? That's your ft. So it becomes 2 pi times minus 1 to 1 dt is 4 pi. Therefore, zero to infinite omega square sine square omega d omega is pi over 2. And because the integral is just dummy, you can just put it as x square sine square x dx. So it looks like there is pi everywhere, even though sine x square over x square, when you integrate from 0 to infinite, has nothing to do with the pi, but the integral result contains pi, right? So it looks like there is a pi everywhere. Another application of Parseval's theorem, maybe I can just do one more example. Is there any questions? Yes. When you have ft, becomes tft. So Fourier transform with this. tft exponential minus I omega t dt. When this Fourier transform is, we know if this function assuming that we know the integral, what will be the result if you have an additional t? You ever seen something? So this is same as actually I d omega t right? if you integrate, if you differentiate this whole thing by omega, what do you get? If you differentiate by omega, you have minus I t in front of here. So if you have additional I, that is hence minus I. So if this time we have this function, and ft is given by t0, t is equal to minus 1 to 1, 0, then in this case, f omega becomes I d omega d times omega over sine omega, right? So it becomes 2I times omega over cosine omega minus omega square over sine omega. So it becomes omega square over 2I times omega cosine omega minus sine omega. So in this case, maybe I so f, let me check omega, right? So using absolute value of omega square is 4 times omega 4 omega cosine omega minus sine omega square, right? Principal theorem, this integral four times square d omega is again 8 times 0 to infinite omega 4 omega cosine omega minus sine omega square d omega, right? The same as 2 pi times minus 1 to 1 t squared dt. Because ft is given by here, right? So that is 2 pi times 3 over 2, I think. 3 over 4 pi. So therefore, this integral, x to the 4, x cosine x minus sine x squared dx is pi over 6. So probably at your home, maybe you can do the following. Okay. Homework. 3, 0. And use Parsifal's theorem to pi derive complicated integrals. You can do that, right? We have done this two cases, so a little bit more complicated case when we have t squared and t to the cube, and minus 1 to 1, and use this possible theorem to obtain some very interesting integrals. So everything will contain pi. You will obtain very interesting integrals, and the result will be resulting result to pi. And the last topic is convolution. So maybe I will let you adjust yourself. Convolution is because I like to use a different notation for the complex conjugate. So it's called Ft Gt, defined as the following: dt t minus t prime gt dt dt prime t minus t prime gt prime dt prime. So it doesn't really matter. Oh, sorry. It must be t prime. The Fourier transform of the convolution, then convolution is the following: complex conjugate, right? So dt is actually dt prime f t minus t prime gt prime explanation minus I omega t t minus t prime, exponential minus omega t prime, gt prime, right? So actually we can do this integral of t minus t prime exponential minus I omega t minus t prime and tt prime exponential minus omega t prime gt prime, right? So it becomes what? Simply g omega. And this becomes I'll just let you copy. So it becomes exponential minus I omega t minus t prime f t minus t prime dt times g omega. So t minus t prime is u, then it becomes minus infinity prime t prime, infinity prime t prime, exponential minus I omega u, f u t u, g omega. But this becomes again minus infinite, right? So this becomes infinite. So this becomes f omega g omega. So the Fourier transform of this convolution form is simply f omega g omega. So that's basically the system response function. That is, I think you are going to learn about this convolution in maybe sophomore or junior when you learn about communication theory, right? Or digital signal processing too. So this basically describes that when you have a system, it is given by some gt, and you input this ft, then what happens is ft g convolution inside of the system. And when you transform this into the omega domain, then you obtain this convolution integral. I think this is pretty much what I prepared for this semester for you. So in this semester, we learned complex variables and Fourier series and Fourier transform. So most likely, question will be checking the Cauchy-Riemann condition, right? And contour integration. Residue theorem, right? I think that for the Fourier transform, I think most likely I will ask a possible theorem. And maybe some Fourier transform. So if you haven't taken my class carefully, and I think by the time you will know the kind of problem that I prefer, right? That's one of the best way to prepare for the final. I mean, study what I will like mostly to ask you, right? So if you have been studying it carefully, then you probably know by now that what kind of problems I like. And most likely I will ask them. That's, I think, good strategy to studying for the exam. Not only for my class, but the other class as well. So any questions for this semester? All right, so that's about it. 종강? Thank you for your attention. Okay. So I hope good luck for the final. In English, you say the fingers crossed. That means good luck. 다음 주는 수업 없어요. 시험 중입니다. 주말에는 처음부터 오는 거예요. 아, 우리다. 우리. 전부 다. Okay. Oh, yeah. Korean.
What?
Korean? No problem.
Yeah.
You're French, right?
No, I'm from Turkey.
Oh, right.
Yeah.
I was confused.
I kind of knew that you thought I was French.
Right. What's your name? Somehow.
My name is Mohammed Tan.
Oh, right. Malta?
Istanbul.
Istanbul.
Yes.
Used to be Constantinople.
Yes. Yes.
There is a very interesting document on Netflix about the Imam and the second who conquered Constantinople, 14 something.
Ah, Mehmet said. Yeah.
Right. Did you know that the Turkish and Koreans are grammatically very similar?
What?
Language-wise.
Oh, yeah. Actually, I'm learning Korean, and structure is almost the same.
Right.
It's just verbal.
Try athlete, right?
Yes.
And so we say house in, house out. Same, right?
Yeah. I will put the verb at the end.
Right. How about, do you have an article?
Article?
Yeah, like the, you don't have that, right?
Yeah, no, we don't.
I see. Okay, maybe you can go to my room to talk. I can give you a coffee.
Actually, I'm all about to graduate.
Uh-huh.
I'm looking for years.
Oh, I see.
Yeah, in next semester I'll go back to my school. And next, I'll take some master's application. And also study.
So, you have been here for 1 year?
No, one semester.
One semester at the exchange student, right? Okay. I don't know why I thought you were French.
I don't know. But I remember one of the first classes you talked about crochet and being French.
Right.
And you looked at me.
Yeah, you look like a French.
Yeah.
I don't know. I see. Good. You run calculus in high school? Maybe everything is Korean.
Yeah, it could be. But actually, they removed part by part, so I don't need that right now.
You show a part.
Yeah.
You don't have to do
No,
that.
not integration, but like they removed important parts of the calculus
All right.
from the curriculum.
Okay, have a sip. You like coffee?
Yeah, that'll be fine.
All right. May not be as good as Turkish coffee, but
That's okay. That's an iMac. From how long ago?
I'm in.
Yeah, it's so old though.
It's almost 20 years old. And I'm wondering, I can still turn it on, but I cannot get into the internet because the OS is too old, I think. Let me see. I have an even older Mac here.
Can I see?
Right.
Oh, those blue ones.
1990, I think 6.
I think I've never seen them in real life.
Oh, really?
Yeah.
I even have a Mac 2 at my
Mac
home.
2. Oh, like the
1987.
oldest ones.
1987.
That's so cool.
Right.
Actually, my major is electrical engineering,
Uh-huh.
but my double major is computer science, and I'm really interested in computers and stuff.
Alright.
So I know.
So my room is really messy.
That looks very nice.
I already teach one class.
This one?
Yeah. So you're coming back to the Turkey this winter?
Yeah.
give my card just in case.
Oh, thank
You
you.
can reach me.
Actually, before, let's say, 5 to 6 months ago, I wasn't even planning to apply for master's study in a grad school because I really wanted to experience like going to a company, being a software engineer, developing things. But after I had a bunch of internships, I decided to go study grad school. I didn't want to be a random software engineer.
So maybe just by accident you took my class and.
So I was wondering, how did you decide to study, and is there anything you would like to tell me about it?
All right. Yeah. Okay. I don't know if it's as good as Turkish coffee, but
Thank you so much.
No worries.
I'm sure it is.
no worries. So other than English, which language do you speak?
Turkish.
Turkish? I know. Other than Turkish.
Yeah,
right?
just a little French, but it's so basic. And I'm learning Korean now.
Korean now?
You know French, right?
Un peu. Parlez-vous français? I just speak survival French. I can ask where is the way or order food or something.
Yeah.
Ask for water. Like est-ce que vous avez de l'eau pétillante? Something like that.
I think I know Korean that much too. I can.
But because there's a one-to-one correspondence in grammar.
Yeah.
I don't know. Do you have a adjective as tense?
Yes. Like all of our tenses are defined like they're getting at the end of
Suffix,
the word.
right?
Yeah, that's suffix.
Maybe same, right? So like she is beautiful. So we say we put tense in the adjective.
Yeah.
So say she is beautiful, but in Korean, 그녀는 아름답다, 아름다웠다, 아름다울 것이다, something like that.
She's beautiful is o güzel. In Turkish, güzel is the adjective part.
Right.
When we make it past tense, it becomes o güzeldi.
güzeldi.
Yeah.
güzeldi.
Yeah. Like güzel is adjective. When you put the at the end of the word, it becomes past tense.
Güzel. How about the future?
Actually, there is no word for like adjective. You cannot make an adjective future because it doesn't make sense. But let's say I'm going is like what is it in Korean? Gayo. In Turkish, it's gidiyorum.
Right.
In future tense is gideceğim. Past tense is gittim.
Same in Korean.
Yeah. I think it will be easy for you.
Japanese is exactly the same as Korean.
Yeah, I know that too.
We just need to replace word by word. So actually I do speak Japanese a little bit. Maybe I should learn Turkish.
You can learn. Have you ever been to Turkey?
No idea.
Oh, not yet. It's a nice place to go.
So your name is Mohammed Chan. So Mohammed is your last name.
No.
Your first name.
My first name is Mohammed Can.
Mohammed and Chan is.
Can is my first name too. Durmuş is my last name.
Oh, I see. Your last name again?
Durmuş.
Yumuş.
Actually, about complex analysis, I knew a bit from high school and also undergraduate studies, but I've never studied that much. And I took the course because I had to. There was another class in English that I could take. All of them I either took it or were in Korean. But after taking this, I kind of like it and started to watch videos about it, read books about it. It is very nice.
So did you like this integrals? Residue integrals?
Yeah, actually, residue integrals are so. It is mesmerizing. How did you think about it in the first place?
Right.
I don't think I would be able to come up with that in the first place. But thinking about numbers in a two-dimensional form makes so much sense.
Right. This is a very interesting idea. That It's amazing that in the French they did develop it 300 years ago.
Yeah,
In that.
yeah. I'm applying for masters around this time for the next year.
All right.
I'm planning to apply for ETH Zurich. You know that? At ETH Zurich.
Oh, ETH Zurich.
Yeah, that one, and also I'm planning for EPFL.
Right. I have a few friends in ETH
Yeah.
Zurich, so also I know a few as a startup companies as well. So if you're interested in, I can introduce you.
That would be very nice.
So I know a few professors in Istanbul too.
In
Mostly in
universities?
quantum computing.
Really?
Yeah. So my research area is mostly in quantum computing. So I know a few people there.
Yeah. In which universities?
Let me check.
Ankara, Istanbul?
Let me check. Do you have are you doing some LinkedIn?
Yeah, I would like to.
Oh, I see. So maybe you can do this. You can just.
I didn't know that LinkedIn has a QR code.
So this is you don't exchange it with this guy, just LinkedIn.
Yeah.
So let me check. Here's my new edition. His name.
Oh, you did your master at Seven Nation University.
Right.
Do you think should I apply for Seven Nation University for computer science studies?
Yeah, but I thought you were going back to Spain.
Yeah, I'm going back, but after I graduate from my school, I can come back to you.
Oh, I see. Yeah, you can come back to Korea, or maybe you can apply for ETH. I think it's a much better school.
Yeah, I applied for ETH, EPFL, Technical University of Munich.
Yeah.
To Delft. It is very nice about computer graphics. That's the one I want to specialize in. And also, I'll apply for Yale too.
Oh, Yale is very good university.
So maybe after all, I can apply for Seven Nation too.
Right. So National is not. Yeah. 2 years.
Maybe I can have a message next time.
Oh, Chan, okay. Isn't it? Bilkent University?
Oh yeah, it's in Ankara. It is a very nice school.
Yeah, he's a very nice guy. His name is Kian Okay.
Cihan.
Jihan.
Yeah. In the C in Turkish is pronounced as this kind of colon.
Oh, Z.
Yeah.
Jihan. Jihan. So it's called Altay language in Turkish, Hungarian. But Hungarians are a bit more complicated.
Altaic language is Turkish Altaic language too.
Right, Turkish and Finnish.
Finnish, I'm not sure.
I had a chance to visit the Finland about 40 years ago. I spent 2 weeks there. A chance to linguist at Tampere University, and that we discovered it's the same grammar.
Oh yeah.
I have read house in, house out, table under, table up, right? Over. So everything is on the suffix.
Yeah, actually, in Turkish it's somehow different from Korean about the on top of thing. You say bak.
Yeah.
Table bak is
table
on
back.
top of.
On top, right.
We say masanın üstünde. Like it's on top of the table, but reverse order. Table on top of the
table on top. We have table we.
Table we.
We is like up above. Table 아래.
Oh
yeah.
Below. It is like that too.
Right.
Also,
house out, house in.
What was it?
What is the Turkish name for daughter?
Daughter. Kız.
Kız. How about fire?
Ateş.
Water?
Su.
River?
Nehir. but mandu and manti is the same.
Mountain?
Mandu.
Mandu?
Oh. We have manti, the
Yeah,
dish.
yeah.
It's mandu in Korean.
Oh, I see. Actually, kebab is one of my favorite dish.
Mm-hmm.
There is one very good place when you go to Sam's West.
Really?
Yeah, there is one kebab place in 무슨 Itaewon?
There are so many things in Itaewon I want to
Right.
try, but
Right.
they were not good.
So I see. So you're staying in the dormitory?
Yeah.
Oh, it's not bad, right?
It is very nice. Actually, the first time I came here, I couldn't eat anything. I'm not Muslim, but I was raised in Turkey you cannot find any pork. Nobody eats
Right.
pork. That's why I haven't eaten any pork yet. So I couldn't eat anything. I wasn't sure if it was pork or not.
It's mostly pork or chicken. How about
Yeah.
chicken?
Chicken is fine.
Fine.
Only pork.
Oh, I see, pork.
So the first week I couldn't eat anything, but now I just know places to go. I really love Korean food.
I think the reason why in the Middle East and Muslim pork is very easy to get spoiled. It's the hard weather compared with the cow or
Chicken?
chicken. I don't know. Chicken is
I think chicken is the same as yours.
same as pork, right?
Yeah.
So probably for the religious reason.
Most probably yes.
Right. But basically, the Islam is the same Bible, right? The old Bible.
Yeah.
Old Testament is the same, right?
Most
Quran,
of stories are
story
the
is the same.
Yeah, we accept Jesus.
Except
as
the
our
name for the
prophet.
God.
Yeah.
Allah, Yahweh, oh. So I found the Finnish and Turkish. But when in Finnish, some words, actually they say su for water.
Really?
Right.
I think Chinese say soup.
Su, right.
Also, in the old times,
I know you used to live in near Manchuria.
Yeah.
This food.
Probably it was interaction.
Right. So maybe, in a way, we are related.
Yeah.
Definitely, I think so. And your totem is bear or wolf, right?
Yeah.
Wolf.
How about Korea?
We use bear. But in the old story that they say bear and tiger used to live together.
Tigers who?
Tiger, but they have a big fight and tiger left.
Tiger represents which nationality?
I don't know. So tiger can be replaced by wolf.
Oh.
So maybe in the long time ago, maybe wolf or clan represented by tiger.
Yeah.
Maybe or our clan represented by the bear. Maybe lived in the same area. And some, yeah, right. And they say, according to the legend, there's a tiger left and go their own way to the west.
Yeah. It kind of overlaps with this story.
Right. So we are the descendant of bear.
How did you get into computing, quantum computing?
Oh, that's the old story. I went to University of Illinois for my PhD. And after my PhD, I went to IBM. IBM.
To work?
Yeah. Thomas J. Watson Research Center, which is opposite New York. And I happened to be in quantum group. So I was introduced to quantum computing and communication in 1988, about a very long time ago.
Yeah, it's basically the start of the things.
Yeah. Even before the start of things. We are talking about the quantum computing here. And then after some time I had to come back to Korea to fulfill my military duty. Do you have a military duty or mandatory or?
It is mandatory, but you can give money and stay.
How long is it for if you make
6 months.
6 months, not bad. In my time it's 3 years.
Yeah, old time it was like that.
3 years. But I have an option to work for the defense company. So I choose to work for LG.
Yeah. Or instead of mandatory duty, you can work in a company?
Substitute.
That's
Substitute. It's for 5 years.
Oh.
So
It's okay, you have worked.
but it's, you paid well.
Mm-hmm.
So I worked for like a defense industry. I was in the group for Korean destroyer developing later.
I had an internship somewhere like that in Turkey.
All right.
It's the Turkish Nation Defense Company in Samsun.
Right.
It was literally we were doing. I was developing a TCP to message queue adapter
Right.
for a real-time voice system. There were literally tanks going on. Somebody's, soldering things with
Right.
tank parts.
Right.
It was cool.
So I was teaching like basically microwave theory to the research engineers for 5 years at the
Yeah.
company. So we were doing like very complicated microwave things to the radar and tracking and everything. It was mostly for developing mathematical tools. It wasn't that bad. And then after finishing my degree, I was either thinking go back to the state or find a job. But this university invited me to.
So you are here.
So that's the reason I stayed here. Stayed for almost 30 years.
Do you do research on quantum computing here?
Yeah.
I think they developed. I think Google developed 58 qubits.
Right. Supplement credit, right.
That's amazing.
So I've been working for quantum computing for almost 25 years. And the government was very generous to provide enough funding for that. So,
Yeah, it's semi-quantum too.
Right.
If you have it, you can crack anything,
Right.
Because of the computing.
Right. So this is a standardized the taste, but it's not as good as the Turkish coffee, right?
Have you tried Turkish coffee?
Oh yeah,
Yeah, it is.
it's very good. I actually have a hand grinders. I bought in France, but it's Turkish.
Yeah, I think Turkish coffee is different from that because you put the coffee with the water at the
Right.
same time.
Yeah.
That's why it just kept together.
That's right, exactly. You speak German as well, or?
I learned in high school. I don't remember anything.
Yes. I had 2 years of German in high school too. I never used it.
Yeah.
French is constantly more useful when I go to travel to Europe. Canada, Quebec, they speak French.
Yeah. Actually, before coming here, I was going to Canada for Toronto University as an exchange student. That was my plan to go, but I had to get IELTS test.
I see.
IELTS, right?
Yeah.
And it kind of, the results were announced a bit late, so it was over the deadline. So I just selected random schools without doing it.
So what made you come over to Korea?
Yeah, actually I wasn't planning to come because if it wasn't Toronto, okay, I'll stay in my school. But then they said, yeah, you can go to Seoul. I said, okay, whenever I'll try this.
University of Seoul I think it's okay university.
Yeah, it is nice.
Not as good as the Seoul National, but still okay.
The thing is, before coming here, I couldn't find anything online about University of Seoul because everything is probably in Hangul. So when you write University of Seoul, there is no new presence.
Right.
So I wasn't sure if I was scanning, is this a real school?
Do you know why I teach in my class in English?
No.
It's about 25 or 6 or about 20 years ago. So I don't know why, but initially I have been teaching the mathematics ever since I came back to this. I joined this university since 1996. But I don't know why, but my class is always full. So I thought, okay, if I teach in English, they might reduce the number of the students.
Oh. Then did it get crowded?
Actually, it didn't work out.
Yeah.
Same number of students.
Because if it's English, I think exchange students just, it's English. I should
Right.
take it.
I didn't figure out that yet. So always like 100 and something. I usually prefer like a school class size of about 50 or 60. That is more comfortable. But it's always very crowded. 120.
Yeah.
So I don't know
maybe that's why
But-
people love complex
but-
analysis.
I mean, another professor is offering the same class, but it's always like 20-30 to that class.
Oh.
And most of the students just took me. And some students even asked me to extra, like, see it or something. So I don't know why.
I don't know if student gossip, but maybe they think we are giving more points. And then,
Not really. Also, I give more quiz, right?
I was really surprised when you said, yeah, you will write your name and the quiz is over.
That's just for give a point.
Yeah, I see. But
It's
I
only 5
wasn't
points.
expecting it. I was like, okay, when is the question coming?
Right. I just give students 1.5 points or 10
So,
points.
in the end of the class, do you do curve or there is a scale for the grades?
Just for this. I'm usually quite generous. So, how did you do your 2 quiz?
The second one was nice. I'm happy with it. First one, I was happy, but I think I made a bunch of completion mistakes.
Okay.
Not theoretical, but completion. Yeah, it was nice. I'm happy.
So, you didn't have any problem with my English, right?
Yeah, it's okay.
Some students ask me, sometimes I speak too fast.
I think the feedback I'll give about your class is that you are, writing
Right.
equations. After one point, you cannot comprehend them.
Right.
Yeah, I'm like,
That's the reason I put it in the YouTube.
yeah, that if that wouldn't happen, I don't think many people would understand, including me.
Right. So YouTube is helpful, right?
Yeah.
You can just
Because
repeat.
it really requires time to understand one line of thing you wrote.
Right.
Just stopping them and trying to understand how to edit.
So sometimes I know that I'm moving really fast, and my handwriting is not very good.
Yeah. The handwriting is still okay. Maybe you could include some, background stories.
Right.
Not about, how this was derived, but
Right.
how it's useful.
Right.
I watched the YouTube. Do you know Tribune One Brown? It's a guy, creates math videos.
Right. Right.
I watched his, I think, 6-hour complex analysis video. It was a live stream. He literally uses, how do we use this in normal life. Actually, he explains how actually multiplying two things corresponds to
Right.
rotation,
Yeah. Right.
two-dimensional axis and stuff. It makes it really easy to understand.
That's right. Well, I should do that. So do you have snow in this country? Probably not, right?
Yes, we
It's
have
a military. You have
snow.
snow.
Like snow.
Yeah, snow. Yeah.
Yeah, we have in the summer.
You have winter.
Yeah.
Oh, I thought it's Mediterranean weather.
Actually, in Turkey, it's right in the middle that when you go a little bit south, it's Mediterranean, but Istanbul is not snow.
I see. So Istanbul, I think that area used to be like a Troy, right?
Troy?
Yeah, the Troy War with the Greek.
Oh,
13th century BC.
it is a little bit north from the Troy.
Oh, I see. So it's Asia Minor, right?
Yeah.
That is a Troy area. I know the area.
Actually, yeah, that part is Troy. That part
All
is
right.
Troy.
Istanbul is
That is
Istanbul, right? Okay.
So that part is usually labeled as Mediterranean part.
Right.
This is very similar to Korea.
Right.
This part is.
Yeah.
Because I think they're on the same degree.
Yeah. Right. So
Yeah.
I see. Oh, I see. And after the Troy War, I think the name is Ionis. They left and go south. Ionis.
Ionianlar the same.
All right.
Turkish.
Yeah, they left.
Ionians.
Ionians. And they left and then settled down and
Greece.
become Italy.
Yeah.
They become the ancestor to the Rome. So about 500 years before the Romulus was born.
Yeah.
So Troy become the Italian Romulus. And
It is very nice. Like in Turkey, when you go, you can see the stack of nationalities
Right.
and most of the
Right.
countries together.
Right.
Like when you go to the place I showed you, you can see just needs you can find some Ottoman things.
Right.
It is nice.
So it's like it's always become a circle.
Yeah.
Troy become Rome, Rome become like a Byzantine,
Mm-hmm.
and then become Turkey,
Yeah.
and then circle is closed.
Yeah.
Maybe we have a common ancestor. Do you know? Are you familiar with
Sumerian?
Sumerian
Yeah.
in Akkadian, about
Mhm.
3000 BC.
Yes.
I happen to have the Sumerian grammar books. In
Oh.
Amazon, you can find that.
In Amazon?
Yeah.
That's so nice.
Yeah, 1920, the University of Michigan professors wrote and published a book on Sumerian grammar. It's Altai language.
Oh. I didn't know that.
Sai, apple, it, housing, house out.
Mm-hmm.
How many vowels do you have?
Vowels, 8 vowels.
8 vowels.
Actually, Turkish as a language stayed, but it changed so many alphabets.
Mhm.
You know, in old times, in the ancient alphabet, we were around here.
Right.
There is a Göktürkian alphabet. Maybe you're similar, it's kind of similar to Korean or you know, East Asian types of things.
Like a circle, like square.
Yes, squares, you know,
Yeah,
lines
right.
and stuff. And then after I think Islam,
Islam.
you start using Arabic letters.
Arabic, right.
And then around 1928, Atatürk came and changed it to Latin alphabet.
Latin alphabet. Right. What's his name? Kamil Pasha.
Yeah, Mustafa Kemal Pasha.
Right, Mustafa Kamil Pasha changed it into the Roman alphabet, right?
Yeah, yeah. So we have A, but we pronounce this as A.
A,
Then we have E, we pronounce it as E.
E.
We have, you know, there is E, there is I letter in English. Without
I.
dot,
Without dot.
we say it U.
U.
And with dot, it is E.
E.
Then we have U,
U.
English U.
U.
If we put dot, 2 dots on it, it becomes U.
U.
Then we have O, English O.
O.
With 2 dots, it becomes
U.
O.
U.
Yeah.
Like French.
Yeah.
Oh, Korean actually have 5. A, E, U, E, O.
Yeah, but I think it's so hard to get the difference between, you know, that's O, like L.
U, yeah. But
And
we
normal
put
O.
two vowels together.
Yeah.
So we have a U, E. So actually we have 19 vowels.
19?
Yeah. Only 5.
But combined
them together.
Yeah.
We have about 19.
Yeah.
That's the reason why the foreigners think Korean pronunciation is very different.
Yeah.
So something like that.
Yeah, I don't get the difference between also 2 B's, you know, bang and bang.
Bang,
Yeah, I really don't get the difference and then 2 consonants.
Two consonants. Oh yeah.
Like
G,
G.
But probably in Italian you have a P, B, ba, pa, ba.
Yeah, pa and ba different.
Right.
I don't get when it's like
G,
G.
G. Right.
I try to say it, but my friend says no, it's not
Good,
like that.
good. Also, you put sometimes consonant in the bottom.
I watched a YouTube video about Korean saying that in old times Korean has vowel harmony. You know what vowel harmony
yeah,
is?
right.
But now it doesn't have. So
Yeah, we are not using that anymore.
in Turkish we have vowel harmony and it's highly used.
Oh, I see.
Maybe it suggests that they're coming from
Right. Maybe ancient times.
Yeah.
But you're lucky you don't have to use the Chinese.
Yeah.
But you use Latin, right? Latin is more complicated.
Than Chinese?
Latin, I mean, in Latin, the verb has a very different changes, right? There are different way of verb changes in Latin. 160.
What do you mean?
Latin language. Latin.
You mean Latin alphabet or Latin language?
Language.
I don't know which one.
Oh, I see.
It will be hard. thing with Turkish is, like compared to French, let's say, or another European languages, in Turkish every letter has a sound corresponding with it,
Right.
and you just read it like that, just like Korean.
Right.
You
French,
don't have-
sometimes they don't pronounce.
Yeah, there are
Especially
so
last
many
one.
things, and you don't pronounce the last
Right.
ones. Mhm.
That's right.
So even if you don't know any Turkish, you can still read it.
Read, right.
Yeah. Just like I can read any Korean thing.
So you can read.
Yeah. I
Once
can
you know
read.
the alphabet.
Yeah.
Same for the Finnish.
Really?
Yeah.
I didn't know that.
They also recognize the alphabet, but different.
Mhm.
The Finnish is actually more like a something strong sounds.
Mhm.
I don't know about Hungarian. They say Hungarians also are Thai language.
Yeah, actually we say that. Actually we don't say that, it's a historic thing. When Turks are going back to West,
Mhm.
some of them come to Anatolian part, and some
Anatolian,
of them
right.
go from upper
Mm.
side to Europe,
Mhm.
and Hungarians are Turkish as well. And actually they're in a Turkic community thing too.
Right.
Hungary.
Yeah. It's called Huns.
Yeah.
I think 280 or something.
Yeah. I didn't know that you would know it, so I didn't say the name.
Huns.
Mhm.
Huns.
It's like in our historical we say that this is Anatolian Huns, this is European Huns.
Mhm. And actually, there is a theory that Koreans are descendant of Huns too.
Really?
A long time ago.
Mm.
I mean, we had the communal system
Mhm.
about maybe 10th century BC.
Yeah. Yeah, I think this nationality things come from our isolation.
Right.
You are Korean because you try to you have a separate country from Chinese
Right.
or other people. And
And
as
you-
the time goes by, you really get different.
Right. And Turkish and Finnish you mixed with the Europeans.
Yeah.
So become more like Caucasian.
Mhm.
And we probably mixed with the Chinese.
Yeah. Actually, in Turkey, I think it is mixed so much.
Mhm.
I don't know, there is probably Arabic, Persian,
Right.
European too.
Too right. Same as the
also-
Finnish.
Yeah.
But it's amazing that language survives.
Yeah, right. In the end, there's so many common words in Persian which affect from Arabic.
Right.
But it's still Turkish.
Turkish, right.
Like I can still get a bunch of words from Kyrgyzstan, Uzbekistan.
Right.
They are Turkish states. too.
Right. It's also like Uzbekistan and
Uzbekistan.
those also
Yeah.
Tatar.
The road we came.
Same.
Still there.
Ethnically, I think we speak the same, probably same language group. Maybe not exactly the same, but
Yeah.
right.
I think there is Ural and Altai.
Ural, Altai
languages.
language,
We are
right.
from the Ural
Right.
part. Korean from Altai part, but I think it's a Turkic.
Our language is Altai. Where is more northern part, right? Siberians.
Yeah.
The American Indians, for example.
American Indians?
Yeah. They moved to the America about 20,000 years ago.
I didn't
Through
know that.
the Bering,
Hmm.
Alaska.
Oh. Are they living in Alaska now?
No, they in the main America and Canada. American Indian.
I thought they were there later on.
They came from the similar area with us,
Mhm.
but they separated us from about 20,000 years ago. So their language might be different.
Yeah.
But we have been living in the similar area for about 2,000 years ago. So because then even though it's retained the similar,
Do you know Chinese? And
I can read Chinese characters.
most of the people in Korea is able to read Chinese characters. I don't know why.
Because it was mandatory in elementary school and high school.
Really?
Yes.
Why?
Because ancient times we used the Chinese characters as it's like a Latin.
Or King Sejong.
Yeah, until King Sejong invented the Korean alphabet. But actually, even before him, there was a Korean alphabet. But for educated people, they use the Chinese.
I see.
This is like a Latin,
Yeah, I see.
and then the Euro. So, I mean, old books are mostly written in Chinese characters. That's the reason why we were forced to learn But now mainland China use a different character. They simplify
Oh, Mandarin.
Mandarin.
Mm.
So we have been taught the traditional form of Chinese characters.
Cantonese?
No, it's still Mandarin, but the characters, the Chinese character, is we use the original one that used by Ming Dynasty.
Oh, I
But
see.
after the Communist Party occupied China, they simplified. So it's no longer the same character.
Yeah.
So only Korea, Japan, and Taiwan use the traditional form.
So what do you think about North Korea?
Oh, crazy.
Right?
I don't know. It will be very difficult to get maybe someday there will be some unification, but it's like we have to feed 20 million people
Yeah,
if
and
you get united,
the culture
unified,
is I think so different.
cultural different. And they have a nuclear bomb, but I don't know. So something crazy, I think.
Yeah. And also today I think they announced a martial law.
Martial law, right? President here.
Yeah.
And then abolished, and then destroyed.
Yeah.
So there was some political struggle between the opposition and then, I don't know, I think he made a mistake.
I think so. I think it was like everybody I watched and I told say that it was out of nowhere.
Right, just 6 hours.
Yeah.
Until I was in the college in Korea was under the military dictatorship. And then somehow it became democratic for the last, I don't know, 40 years or so. So it's very difficult to go back. I don't think so.
My friends tell me that in 1980s
Right.
there was a
Horrible time.
Yeah. He said like people from that time would probably be Soviets.
Right. I was a sophomore at the time. And it was a very sad period.
It's so, I think, funny that the same thing over and over happens everywhere. In Turkey it happened too, it still happens now.
Right. So your president is a little bit like a strongman, right?
Strongman?
Dictator?
Yeah, that's right.
But I thought Turkey is a more democratic country, right?
Thanks to Atatürk it is, but now Erdogan is trying to oppose Islamic things. Actually, I don't think he's even a Muslim, he's just trying to get...
But he's not a fundamental, Islamic fundamentalist, isn't he?
He is.
He is?
Yeah.
Oh.
And he tried to oppose ideas to us,
Oh, I
and we
see.
just don't want it.
So you like to make Turkey like Iran?
Yeah.
Oh. That's bad.
That's so bad.
I think the religion has to be independent from the politics.
It has to be, and actually it is because of Mustafa Kemal Pasha, but now he just tries to do it again so that I think he
I
would
see.
have
He
more
might
power.
go back. He might want to go back to the Muhammad II.
Yeah.
I think he's a great man.
Erdogan?
Yeah. No, he's not. I mean not this one, the old one,
Yeah, we love him.
who liberated Constantinople.
Yeah.
Conquered or liberated.
Do you know the story about it?
Oh yeah.
Like they make the ships go from the
Yeah.
land to go back.
Right. I mean there is a document in Netflix.
Oh yeah, I remember it.
I watched it. Very beautiful. Yeah, it's a very good document. So when you go back to Turkey?
I will go back around 26th of January next
Oh, I see. So 1 more month.
I'm
Okay.
planning to visit places in Korea.
Have you been to the palace? And of course, you did, right?
To where?
Paris?
Gyeongbokgung.
Gyeongbokgung?
Yeah.
How about the other one? P1?
Yeah. I went to many places in Seoul. I went to Sokcho for Sarasan Mountain.
Oh, I see.
Actually, it was a nice place. I went to Sambavirak and also a Buddhist temple in a cave.
Oh, I see, yeah.
It was very nice.
This time the deciduous trees is not very beautiful. I don't know why, but
What?
the Satanfu, the colorful trees. I mean, the color changes when the autumn, but
It becomes red.
it becomes red. But we had a very hot summer this time until I think early October. So the mountain still like green,
Yeah.
greenish yellow, something not very beautiful.
Actually, I was surprised at how red the leaves become because when it's autumn time, in Turkey it's usually kind of orange yellow, not
yellow.
that bright red.
Oh, I see.
But I took a picture of the
Oh yeah,
leaves.
in this campus too, right?
Yeah, it's
Completely
the
red.
reddest.
Oh, you never seen that before?
Yeah,
I see.
it is nice.
I see. So when you have trouble understanding the problem, just don't hesitate to lend to email or you can even text me.
Oh, thank you so much.
No worries.
Yeah, I'm planning to study actually from today.
Oh,
for the
yeah.
quiz,
You have 2
because
weeks.
I won't have time in 2 weeks.
Right. Right. Okay.
Thank you for the coffee.
Oh, no worries, you're welcome. All right.
Nice.
So, it was nice to talk to you.
Yeah.